my channel. My name is Nikhil. Today's topic is corrosion. Now let us see what is corrosion. Corrosion is a natural process that converts a refined metal into a more chemical stable oxide. It is the gradual deterioration of materials by chemical or electrochemical reaction with their environment. Now let us see a video on corrosion, the types of corrosion, the prevention of corrosion, and the electrochemical theory of corrosion.
Have you ever wondered why metals corrode over time? Today we're going to unravel the mystery behind this fascinating phenomenon known as corrosion. Imagine corrosion as a journey where refined metals transform into a more stable form. They're oxides, hydroxides, or sulfides. It's a natural process that's constantly at work, breaking down our shiny metallic objects into something entirely different. Intriguing, isn't it? Now that we know what corrosion is, let's dive deeper into the two primary types, dry and wet corrosion. First, let's explore dry corrosion, also known as oxidation. This process is a fascinating dance between metal and oxygen. Picture a metal, say, iron, just sitting there, seemingly unaffected by its surroundings. But when the temperature gets cranked up, a whole new story unfolds. The oxygen in the air, ever so eager to react, pounces on our heated iron, binding with it to create a new substance known as an oxide. This oxide, you may know it as rust, is the telltale sign of dry corrosion. The reaction creates a layer that coats the metal, and while it may seem protective, it's actually quite the opposite. This oxide layer can flake off, exposing fresh metal to the oxygen, and thus the cycle continues. So in essence, dry corrosion is a slow but relentless process, where our everyday metals gradually transform under the influence of high heat and oxygen. Next, we'll look at wet corrosion, which is quite different from dry corrosion. Wet corrosion, on the other hand, involves a liquid medium. This fascinating process kicks off when a metal surface makes contact with water or a moist environment. This interaction is not as friendly as it might seem, unfortunately. The metal and water don't just shake hands and part ways. Instead, they react, with the metal often forming hydroxides or sulfides. Imagine it like this. The metal is at a party and water is the guest, who instead of just making small talk, starts to change the metal's whole personality, morphing it into something entirely different. This transformation is what we refer to as wet corrosion. It's a chemical reaction that's as complex as it is captivating. So the next time you see a rusty pipe or a corroded car part, remember it's not just neglect, it's chemistry at work. Now that we understand dry and wet corrosion, let's move on to the electrochemical theory of corrosion. The electrochemical theory of corrosion helps us understand why corrosion happens in the first place. Now let's delve into the heart of this theory. It proposes that corrosion is fundamentally an electrochemical process, which means it involves both electricity and chemistry. This process consists of two simultaneous reactions. First, there's oxidation, also known as the anodic reaction. During oxidation, metal atoms lose electrons and transform into ions. This is where the corrosion process kicks off. Simultaneously, there's a reduction or cathodic reaction taking place. In this reaction, these released electrons are consumed by substances in the environment, such as oxygen or water. These two reactions together constitute the electrochemical process of corrosion. It's like a dance, where one partner can't move without the other. It's this interplay that leads to the degradation of the material over time. With this understanding, let's examine the different types of corrosion. There are several types of corrosion, each with its own unique characteristics. Let's start with uniform corrosion, the most common type. This is the process where the entire surface of a material corrodes at an even rate. It's like a slice of bread, turning uniformly brown in a toaster. Next is pitting corrosion, a localized form of corrosion that results in small holes or pits in the material. Picture a piece of Swiss cheese, and you'll get the idea. Then, we have galvanic corrosion, which occurs when two different metals come into electrical contact through an electrolyte, such as salt water. It's akin to a schoolyard bully, where the stronger metal picks on the weaker one, causing it to corrode. Crevice corrosion is another type to consider. It's a localized form of corrosion that occurs in stagnant locations, such as under gaskets, washers, or insulation material. Imagine a secret agent hiding in the shadows, slowly causing mayhem. Lastly, we have stress corrosion cracking. This occurs when a corrosive environment and tensile stress combine, causing the material to crack and fail. It's like a high-pressure job pushing you to your breaking point. Knowing these types helps us choose the right method to control or prevent corrosion. Corrosion might seem inevitable, but there are ways to control it. Let's dive into some of the most effective methods. First up, material selection. It's a straightforward concept. Choose materials that are inherently resistant to corrosion. For instance, stainless steel and aluminum alloys are often used in environments prone to corrosion. The key here is understanding the environment and choosing materials that can withstand its corrosive effects. Next, we have protective coatings. These act as a physical barrier between the material and the corrosive environment. Paints, lacquers, and varnishes, for example, are commonly used coatings. But it's not just about slapping on a coat of paint. The type of coating and its application need to be carefully considered to ensure effective protection. Then there's cathodic protection, a method particularly effective for protecting metal structures. It works by making the material to be protected act as a cathode in an electrochemical cell. This prevents the material from corroding, while the anode material corrodes instead. Lastly, let's talk about corrosion inhibitors. These are chemicals that slow down or prevent corrosion. They can be added to the corrosive medium or applied to the material's surface. The right inhibitor depends on the type of material and the nature of the corrosive environment. By understanding and applying these methods, we can significantly reduce the harmful effects of corrosion. Let's quickly recap what we've learned today. We've delved into the intriguing world of corrosion chemistry, starting with the definition of corrosion, then discussing dry and wet corrosion. We've explored the electrochemical theory of corrosion, which is the bedrock of our understanding of this phenomenon. We've also looked at the various types of corrosion and ended with a deep dive into corrosion control methods. Remember, understanding corrosion and its control methods can save a lot of time, money, and resources in the long run. Keep exploring, keep learning.
Thanks to video today, it helped me to generate the video.
Have you ever wondered
Now we'll see the summary. Corrosion is a natural process in which a refined metal converted to a chemically stable form, such as oxides, hydroxides, or sulfide. It is the gradual decomposition of a material, usually metals, as a result of chemical or electrochemical reactions with their surroundings.